Welcome to Mastering Machines, where we discover tomorrow's reality.
If you had a group of scientists at your disposal to conduct any type of experiment that you would want, how would you use them, and then what would you use it for? With this new AI paper that was released, this might become more of a reality than what you think. Hey everyone, today we're diving into a paper that was created by AMD and Johns Hopkins University called the Agent Laboratory, the future of AI-assisted scientific research. It isn't just a regular AI SaaS tool, it's an actual comprehensive framework that could change the game for how researchers do their work and how they could do it faster using AI and LLMs. Historically, scientific discovery has been a lengthy and expensive process. Researchers often have to prioritize which ideas to pursue based on predicted impact, leaving many promising concepts unexplored. But Agent Laboratory aims to solve this by creating an AI-powered research pipeline that can help scientists investigate multiple ideas simultaneously. So let's break down how this all works. Agent Laboratory uses a team of specialized AI agents working together. They have a PhD agent that handles literature reviews and research planning. They have a postdoc agent that collaborates on experimental design. They have a machine learning engineer agent that handles code and data preparation. And they even have a professor agent that oversees the final report writing and how it will actually look in the paper or report. These agents work through three main phases to get their work completed. First, they have the literature review phase. The PhD agent uses the ARXIV API, and if anybody doesn't know, ARXIV is basically where all of the scientific papers are uploaded to. And they use that API to find and analyze relevant papers, and it can summarize those papers and extract full text from them and build a comprehensive review of existing research. The second phase is the experimentation phase. This is where it gets really interesting. The system includes something called MLE Solver, a specialized module that can generate, test, and refine machine learning code autonomously. It works through command execution, so it writes and modified code, the code execution, which is testing and debugging the code. It uses program scoring, which evaluates how well the code meets research goals. And then there's also a period of self-reflection, yes, self-reflection from the actual agent, where they're learning from their errors and improving future attempts through the experimentation phase. And then lastly, there's the report writing phase, which is using a module called Paper Solver, and it creates academic reports following standard conference submission formats. The system can even generate figures and maintain proper LaTeX formatting. And LaTeX formatting is a formatting convention for most research papers. Now let's talk results of the Agent Laboratory experiment because they're really fascinating. First, the researchers tested 3 different AI models: GPT-4o, O1 Mini, and O1 Preview. And here are some of the insights that they found in regards to these AI models in context of the Agent Laboratory. O1 Preview achieved the highest usefulness score of 4.4 out of 5. O1 Mini led in experimental quality at 3.2 out of 5. And all models showed strong report quality ratings around 3.0 to 3.4 out of 5. One of the more interesting tidbits of the actual paper that they put out was when they tested it on real world machine learning challenges, Agent Laboratory's MLE Solver outperformed existing systems. It earned 4 medals, 2 gold, 1 silver, 1 bronze in benchmark tests. It achieved above median human performance on 6 out of 10 of the benchmarks. And it maintained consistent high scoring across different types of challenges. The fact that this experiment can produce all of these great scores and benchmarks, and it's probably going to be the worst it will be and it'll only get better, lets you know kind of where we're heading when it comes to scientific research. The Agent Laboratory system has 2 different modes, an autonomous mode and a co-pilot mode. The autonomous mode is where it works independently and after receiving the initial research idea. So it's just, kind of pushes the idea out to it, and then it works it from scratch. Then we have the co-pilot mode, which is where researchers can provide feedback at each stage. So after completing one of the stages, a human in the loop can determine whether they want to go on to the next stage or review it and do that particular stage over again. So I think that having these two modes is definitely useful for the average human researcher or scientist. Studies showed that co-pilot mode papers scored significantly higher, averaging 4.38 out of 10 compared to 3.8 out of 10 in autonomous mode. This demonstrates the power of human AI collaboration in research, and then also having that just human in the loop when it comes to research. Now let's talk about some of the limitations of Agent Laboratory and some of the challenges that they have to address. So the first one being that the papers that were created through Agent Laboratory still score below the average accepted neural IPS paper score of 5.85 out of 10. So there's actually a lot of room for improvement when it comes to that, because even when you look at the average scores from both modes, one was 4.38 out of 10, which was the co-pilot one, and then 3.8 out of 10, which is the autonomous one. Also, the system can sometimes hallucinate experimental results, which is obviously something that you can't afford to have. There are limitations in figure generation and repository management. And then also the automated review system tends to overestimate the paper's quality compared to human reviewers. So I think for right now, for this Agent Laboratory to become even more scalable, there's going to have to be a human in the loop. When I was initially reading this paper, all I could think about was the future implications. So let's talk about some of those. First, researchers could explore many more ideas simultaneously. More time for creative thinking and experimental design. There's going to be faster iteration on research concepts. And there's going to be significantly reduced costs for conducting research. And then also it's going to be more accessible research capabilities for institutions with limited resources. So I ask you all, what potential applications of Agent Laboratory excite you the most? How would you use this kind of AI research assistant in your field, especially if you're in a scientific field? Let me know in the comments below. Looking at Agent Laboratory, we're seeing the beginning of a new era of scientific research where AI works in tandem with human creativity, and they work together to accelerate scientific discovery. Thanks for watching, and remember, mastering machines, discover tomorrow's reality.